So hi, welcome to KMPK Chemistry channel. For this video, I will share with you how I answer PSPM trial question. For this video, I'm going to answer SET KHAS 2 and NSH 2022-2021. Okay, for the first question, it says that an element has two natural occurring isotopes. The first isotope has a mass of 120.9038 AMU and relative abundance of 57.4%, whereas the second isotope has a mass of 122.9042 AMU. So the first question says that calculate the relative atomic mass. Okay, to find the relative atomic mass, we need to use the formula of average atomic mass. So to use the relative atomic mass, we need to know the relative abundance of both isotopes. But now we only know the one of the relative abundance of the isotope. So as we know that the overall value of percentage is 100, so we just need to do subtraction of the relative abundance given here to know the relative abundance of another isotope. So after the subtraction, we begin the relative abundance for the second isotope, and then we now can substitute all the information in this formula. So after we get the average atomic mass, we can find the relative atomic mass, which is the average atomic mass divided by 1/12 times 12. And then now we can cancel out the 12 here and the unit of AMU here, and then it leaves us with the answer of relative atomic mass, which is 1 to 1.7560. And then the second Roman question, it asks us to write the isotopic notation of the element. We need to refer this to the table given in the exam later. So we need to refer it to the table, and we check which one of the element that has the relative atomic mass of 1 to 1.8. So we just need to follow the notation, which is the element symbol, and then the relative atomic mass at the top, and then at the bottom we will write the proton number. Okay, for the next question, for B question, it says that estrogen is a female sexual hormone containing element of C, H, and O with a mole mass of 270.36 gram per mole. The combustion analysis of 1.893 gram of estrogen produces 5.545 gram of CO2 and 1.388 gram of H2O. Determine the empirical formula of estrogen. So to determine the empirical formula of estrogen, we need to find the mass of each element. But now we only know the mass of compound. Which is the mass of CO2 and the mass of H2O. So in order to find the mass of each element here, we need to use formula mass of element equals to molar mass of element divided by molecular mass of compound times mass of compound. Okay, for the first element that I want to find the mass is carbon. For carbon, I need to use the mass. I need to use the compound that contains carbon, which is CO2, and I just need to sub in the information lah. So for carbon, the molar mass of element is 12, and the molecular mass is the molecular mass of CO2, and then the mass of compound of CO2 given here. And then I will obtain the mass of carbon. And then for mass of hydrogen, I need to use the compound that contain hydrogen, which is H2O. Okay, and then for H2O, we have 2 hydrogen. So for molar mass of the element, I need to times 2 with the molar mass of hydrogen, because it involving 2 atoms of hydrogen. So and then the molecular mass of compound, which is H2O, and then the mass of H2O. And then after the calculation, I will obtain the mass of hydrogen, which is 0.1542 gram. I took more than 4 decimal places in order to get more accurate answer, but you just need to use at least 4 decimal places. Okay. Now to find the mass of oxygen, we need to do subtraction, because as we know that the overall mass of the compound is given here, and we already know the mass of C and mass of H. So what's left is only the mass of oxygen, because when we do the subtraction from the overall compound mass, and then we subtract it with the element mass, which is C and H, and then we only left with the mass of oxygen. Okay, now we know all of the elements mass, and only now we can calculate to find the empirical formula of the compound. Okay, after we know the mass, now we need to calculate the mole of each element. So we use the formula mass divided by molar mass, and then we will get the mole answer. It's the same for hydrogen divided by the molar mass, and for the oxygen divided by the molar mass. And then after that, we need to calculate the simplest ratio of mole. So for the simplest ratio of mole, to get the simplest ratio, we need to divide it with the smallest mole among these three. So we need to compare and find which one is the smallest. So I observed that the smallest amount of mole among these three mole is 0.01416. So I will divide all three of mole here with the smallest amount, and then I will get the answer for C is 8.8983, and then for H is 9.8912, and for O is 1. So to get rid of the decimal places, I need to times it with 2, and then only then I will get a round answer, which is for the number of carbon is 18, and number of hydrogen is 22, and for oxygen is 2. And now we get the answer of empirical formula. Okay, for the C question, it says that a bottle of concentrated nitric acid HNO3 solution has a level of 85% by mass, and the density of 0.8362 gram per milliliter. Calculate its molarity. So to find the molarity, we need to know the mole of solute and the volume of solution. But now we know neither one of these information, but we know that the percentage by mass and the density of the solution. So we need to dig out the information from density and percentage by mass to find molarity. Okay. For density, we need to know the mass of solution and the volume of solution. And for percentage by mass, in the formula, we need to know mass of solute and the mass of solution. But now we don't know the mass of solution. So because the similarity of both formula of percentage by mass and the formula of density, the similarity is mass of solution. Both needs mass of solution to calculate the value. So now we don't know the mass of solution, so we need to assume the mass of solution is 1000 gram or 1 kg. It's just the same amount but different unit. Okay. So first I want to dig out the information from density. From the density value, I already assumed that the mass of solution is 1000 gram, and the volume of solution, and now I can find the volume of solution by doing the simple math here, by moving it to the right hand side, and then I will get the volume of solution is 1195.89 milliliter. Okay. The reason why I use gram but not kg here, because I'm following the original unit of density, which is gram per milliliter. So I need to follow the unit of the density in order to use the formula. Okay. And then for the percentage by mass given, I can subtract information of mass of solute by substitute the value of mass of solution that I already assumed, which is 1000 gram or 1 kg. So in this case, I use 1 kg because the SI unit of mass is kg. So I don't use 1000 gram, but I use kg. So I just substitute the value in the formula, and then move it to the left hand side, and then I will get the mass of solute, which is 0.85 kg. Okay. And then after I get mass of solute, I can now calculate the mole of solute by using this formula. The mole of solute equals to mass over molar mass. So mass, because we get the answer in kg, we need to convert it into gram, because in calculation of mole we need to use gram. So just times this with 1000, and then we will get 850. So now we will know the mass. Now we know the mass of the solute, and then now we find the molecular mass of the compound, and then when we do the division, the mole of solute we will obtain, which is 13.4921 mole. I'm sorry, I didn't put the unit. You must need put the unit after each answer. Okay. And now we know the mole of solute and then the volume of solution, and then we can now find the molarity of the solution. Okay. because we calculate the volume of solution from density and obtain the volume of solution in milliliter, we need to convert it into SI unit, which is liter, and the molarity obtained will be 11.28. Okay, next for the E question, it says that the reaction between sulfuric acid H2SO4 and barium hydroxide BaOH2 is shown as below. H2SO4, it reacts with barium hydroxide and it forms barium sulfate plus 2H2O. So it wants us to calculate the mass of barium hydroxide required to produce 4.35 gram barium sulfate if the percentage yield of the reaction is 92%. So the percentage yield here is actually about the product that it produced. So in this case, the product that it produced is barium sulfate lah. So it wants us to calculate the mass of barium hydroxide. So to calculate the mass of barium hydroxide, we need to know the mole of barium hydroxide. And to know the mole, we need to do the stoichiometry method. But to do the stoichiometry method, we need to know the mole of any compound involved in this reaction. But we don't have any mole, we don't know any mole of the compound involved in this chemical reaction. So what we only have here is only the mass of barium sulfate that produced in this experiment. So the mass here is actually the mass obtained from the experiment, which is the actual yield of barium sulfate. So because we already know the percentage yield of the reaction and the actual yield of the product, we can get information of actual yield using the formula percentage of yield. Percentage of yield is the division of actual yield over theoretical yield times 100%. So we just substitute all the information. For the actual yield here is 4.35 gram and the percentage of yield is 92%. Okay, after we do the simple math here, just move it to the left hand side and we will get the theoretical yield of barium sulfate is 4.728 gram. So now we know the theoretical yield of barium SO4. So we can calculate the mole of barium sulfate. So we use the formula of mass over molar mass because we already obtained the mass. We already obtained the theoretical mass of barium sulfate. We just need to divide by the molecular mass of barium sulfate and we will get the mole of barium sulfate is 0.02026 mole. Okay, now we have the mole of barium sulfate. We can do stoichiometry to find the mole of barium hydroxide. Okay, from the balance equation, we can observe that 1 mole of barium hydroxide forms 1 mole of barium sulfate. So we can write as 1 mole barium sulfate equivalent to 1 mole of barium hydroxide. So if 0.02026 mole barium sulfate reacts, how many mole barium hydroxide produced? So to calculate the mole of barium hydroxide produced, we need to use the value of the barium sulfate mole. We need to use the value of barium sulfate times with the coefficient of barium hydroxide in the chemical equation and divide it with the coefficient of barium sulfate in the equation. So we will get the mole for barium hydroxide is 0.02026 mole. Now we know the mole of barium hydroxide. We just need to use the formula to find mass. We times mole with molar mass. So we times mole of barium hydroxide with the molecular mass of barium hydroxide and we will get the answer is 3.4705. So for the next question, for the question, it says that the equation for a redox titration between iodide and chromate ion is as follows. I minus plus CrO4 2 minus, it forms Cr3 plus I2. Balance the redox equation in the basic solution. Okay, the question says that this is a redox. So for in a redox reaction, we know that it's involving compound that undergo reduction and oxidation, right? So later in the balancing equation working, you need to show which of the compound that undergo reduction and which of the compound that undergo oxidation, and we need to label them. So first, for balancing equation, we need first is the divide the chemical equation into two new equations. So to divide the original chemical equation into two new equations is by referring to the substances that are involved in the reaction. So we need to categorize the substances that have the same atom in the product as one new equation. So for I minus, we have the similar atom in the product side, which is I2. So it forms the one new equation, which is I minus, that forms I2. Okay, for the next equation is the second substances that's involved in this reaction is CrO4 minus, and the products that have similar atom as the substances is chromium. So we can combine these two in the second new equation, which is CrO4 minus, that from Cr3 plus. So moving on to balancing the first and the second new equation. Okay, to balance the first equation, we must observe and compare the coefficient and the number of atoms in both sides. So for this case, we can observe that at the right hand side, we have 2i, but for the left hand side we only have 1i. So we need to add 2 in front of the i in order to balance the number of i. So the left hand side and the right hand side, we already equal the number of i. Okay, now we need to equal the charge of both sides. So the left side of this equation, we have charge of 2 times minus 1, which is minus 2, and the left hand side charge is 0. So in order to balance the charge 0 into minus 2, we need to add 2 electrons, because electron has charge minus. So when we add 2 minus, the left side of this equation will be equal to minus 2. So the left side and the right side already balanced the charge. Both is minus 2 and minus 2. So for the second equation, we need to balance it also. So first we need to compare and observe the coefficient of atom at both sides. So at the left hand side, the coefficient of chromium is 1, and the left hand side, the coefficient of chromium is also 1. So the coefficient of atom chromium is already balanced. But at the left hand side, the number of oxygen is 4, but at the right hand side we don't have any oxygen. So we just need to add 4 water molecules, which is 4 H2O, in order to balance the number of oxygen. Okay, now the number of oxygen is 4 for the both sides. Okay, the next atom to balance is, we can observe here that at the right hand side we have 8 hydrogen, but at the left hand side we don't have any hydrogen. So we just need to add 8H plus to balance the number of hydrogen at both sides. So after we balance the number of atoms at both sides, we need to balance the charge. First, the charge of each side. So the charge for the left side is 2 minus plus 8, so we get 6 plus. The charge for the left hand side is 6 plus, and the right hand side the charge is 3 plus. So we need to add electron at the more positive side in order to equal the charge so that both of side will be 3 plus and 3 plus. So at 6 plus, we need to add 3 more electron because it brings minus charge, negative charge. So when 6 plus, we add 3 more electron with negative charge, it will be 3 plus. Okay, now the charge for both sides is already balanced. So here, when we balancing the charge of both of equation, we observe that the first equation is involving the donation of electron, because we have electron at the left hand side of the equation. So it means that I minus donates 2 electron, but for the second equation, we can see that CrO4 minus receive 3 electrons. So it means that when the compound or the substance donates electron, it means that it undergoes oxidation, and when the compound receives electron, it means that it undergoes reduction. So we must put this label aligned with the chemical equation of both equations, because we want to show that this reaction is involving redox. So we need to label the chemical equation. Okay. After we balance both of the chemical reaction, we need to equate the coefficient of electrons, because at the first equation we have 2 electrons, but at the second equation we have 3 electrons. So we need to equate the number of electrons at both equation in order to cancel them out later. So how to equate the number? We just cross multiply, because this first equation has 2 electrons and the second equation has 3 electrons involved. So we just cross multiply this first equation times 3 and the second equation times 2. So after we do the multiplication, we get the new equation. After we get the new equation, we will observe that the coefficient of electron of both equations already equal to one another, which is 6 electron and 6 electron. So now we can cancel out the electron. So the next step after we cancel out the electron is to combine the both of the equation. So to combine, we just combine left hand side with the left hand side and right hand side with the right hand side to make one new long chemical equation. So after we combine, we can observe that we have 16H plus here, because this is actually a basic solution, so we cannot leave our chemical equation with H plus here. So how to remove the H plus? Because H plus represent that the reaction is involving acidic solution, but this is actually a basic solution, so we need to remove the H plus to show that this reaction actually involving basic solution. So to remove the H plus, we just need to add OH minus at both sides of the equation. So we just follow the coefficient of H plus, so we add 16 OH minus at left hand side and 16 OH minus at the right hand side. So 16H plus combined with 16 OH minus will form 16H2O for the left hand side. And the right hand side, we will leave out the 16 OH minus here because we don't have any H plus to combine to form water molecule here. So now we have one new chemical equation here, but we can observe here that we have water molecule at two sides of the equation. So in a chemical equation, we cannot have one type of molecule at both sides of the equation. So we need to move 8H2O here to the left hand side, because this is a plus, so when we move, it will become minus, and 16 minus 8 will become 8H2O, and then the last balanced equation will be 2CrO4 minus plus 6I minus plus 8H2O equals to 2Cr2 plus 2Cr3 plus 3I2 plus 16OH minus.